Good morning, Gavin, Kylie,
Good morning.
and to our not present viewers. That's what we have. We only have 40% of our class present today, so we're going to need to carry it on.
Thanks for the Dr. Pepper, Carson.
Thanks, Carson.
Yes, Carson, you have some appreciative classmates. Anyway, we're going to go over these multiple choice problems, Multiple Monday. So viewers at home, you can just watch this and see if you get it right. Okay, number one, find the following without the use of a calculator. We have the limit as x approaches 1 of x over natural logarithm of x is, I don't know what you got for this. What did you get for this?
1. I got B.
Oh,
though.
wrong. I put B.
Put B?
Yeah.
Okay, let's go ahead and look at this. I don't think that's it. Let's take a look at it. What happens is, the way to do this is to first substitute in to see what happens, right? So if we substitute in, let's say we substitute in, we're going to have 1 over ln of 1, right? And what's the ln of 1? Let's look at it. ln. Now the problem you had is, this was sort of a COVID problem for you guys. ln is log base e. Now that's one of the things that I think we did talk about it a little bit. Yeah, it's the algebra 2. So we did talk about this a little bit last year. So ln is log base e, and so what you're being asked here is what power, the logarithm is what power do you raise e2 to equal 1? E to what power equals 1? E to the what? E to the power of what is equal to 1?
Zero.
E to the power of 0.
Yes, sir.
Yes. So e to the power of 0. So what we have is we substitute in, we get 1 over 0. And so what is this one going to be here?
Just 1.
No,
1 over 0. Oh, non-existent.
it's non-existent.
That's my second option.
Yeah, and to me, of all the problems, this is the one I think that was the hardest of the 4. We'll see how the other go.
I forgot about the...
Yeah, this one too, did you get this one?
I'll try it.
What did you get for this one? Now again, you plug in, you're going to get 0 over 0, right?
Yeah.
So now we factor. Did you factor this thing out?
I was trying to, but I couldn't really see everything. And then I moved on. And forgot that I didn't finish it.
Okay, what we're going to have is, what is the factoring of this thing up here?
X and A. X plus A. X minus
Yeah, so Gavin said, okay, x plus a, x minus a, okay? And what is the factoring of this thing here going to be? A, x squared minus a. And can we factor, oh, excuse me,
A.
x squared?
Yeah.
Yeah, so it'll be this. Okay, so this is unfactorable here. Can we factor this further? Yes, we can. Goes limit as x approaches a. And we have this x plus a here. We have x, well, it's like I'm saying the wrong thing. Okay, I'm going to try to get it right here. X plus a, quantity x minus a. And down here we have x squared plus a squared. And down here, what do we have down here now? X plus a, x minus a. And so now can we cancel some stuff? So we can cancel this, we can cancel this, right? So what do we have left? We have 1 over, right? So now we can go,
That's what I always forget. I always forget to do the 1 over.
so now we have is 1 over, and we can just plug in here for x for a. So we're going to get a squared plus a squared. So what is that going to be? 1 over 2a squared. So that's going to be our answer.
Not the one I made.
What I had done, I forgot to do the 1 over.
Yeah.
I always forget to do the 1 over. That's why I was so confused. Because I got to the second factoring thing, but I always forget the 1 over. And so I was sitting here like, I don't know, and then moved on.
Yeah. Okay, let's go over to number 3. This one here, you know what this one is, right? What is this one? 1/4. Okay, and it simplifies to this over this. And all the others pale in comparison, so that's it. Okay, what'd you get for 4?
I didn't get it.
Let's look down the list.
I had my hand in a circle.
Limit as x approaches a of f of x equals limit as x approaches b of f of x.
No.
Well, here, there's a limit here, but not here.
I didn't see that limit. Oh my God.
So that's wrong. Limit as x approaches a of f of x equals 2. That's looking good. And then limit as x approaches b is 2, no. Limit as x approaches b is 1, no. There's no limit as x approaches b. As x approaches a does not exist, no. Limit does exist, b is your right answer. So that's that.
I didn't see the limit.
Let's go to this next note card.
You want this?
Yeah, you want this?
Yeah, I will, but later. What I want is that other thing I assigned before the break, but that Kylie was working on. Anyway, next we get to graphing f prime of x when given f of x. And here you have all the explanations of what to do. Okay, so to me, these are all good explanations, but the explanation that I think that is better than all of these is this thing we've been talking about. Remember this?
Yeah, the little chart thing.
Yeah, a little chart.
I drew my circle underneath it.
Because this is what tells you, yeah, and there's a circle too. A circle can also be helpful, but especially this chart here, this 3-tiered chart. Then you have plus minus. And so everything derives from being able to access this chart.
I don't have that no part. What are you gonna do?
Yeah.
Yeah.
Okay, so let's, and what it is that you can use a number line just like we've done in the past. So that's my recommendation on these things.
Lines with my plane.
Number lines are your friends, that's right. Glad you remember who your friends are.
Yeah.
Okay, sketch the derivative on the same coordinate plane. Well, it's the same, again, if you take the number line here, if you make a number line, what is your critical number going to be on here?
Is it zero?
0.
Well, I thought
Okay,
it
and
was
if you take f prime and f down here, well, we look at f, and what is f doing in this interval here? F is decreasing, right? So if f is decreasing, what is f prime going to be?
If f is decreasing, f prime is positive?
If prime is negative.
Negative. Huh, I was looking at the wrong one.
Okay, and then we go to the right here. What is f doing here? F is going up, so f prime is positive. So now we can make the sketch. And so if you look at the slopes, right, it's the slopes. So the thing is going to go up like this. It's going to start somewhere like this. We know thing's going to change from negative to positive right here. And to see exactly what it is, it looks like, where does it look like the slope is 1? Do you see that? Here it looks like the slope is a little greater than 1. Slope might be 1 about here at 1.5. So at 1.5, the slope is 1, could be about right here. And the slope -1. So the thing is going to look something like this. That's what the thing is going to look like. And if we look back here, did you see number 4 right here? The degree of any polynomial f prime of x function decreases by 1. And so what this is, this appears to be a like some kind of x squared function, something x squared. So you know the degree of the derivative is going to be decreased by 1, and so that's how you get a line from that. Okay, now, so now you can do the same thing over here on 2. And where are the critical numbers going to be here? Gavin, what do you think? Where are the critical numbers going to be here for this one, Gavin? What do you think?
On what? -5, 6. I don't know.
I don't know. Okay. What you're looking at is this thing right here. What you're looking for, your critical numbers are going to be where f, you're looking right here, where the thing is changing from increasing to decreasing or decreasing to increasing. Where do you see changes from increasing to decreasing or decreasing to increasing here? Where do you see that?
-3.
So about -3. So let's go ahead and put, that's going to be one of our critical numbers. And where's another one?
1.
About 1. And now we can go ahead and what is, and we put our f prime, what is f doing here to the left of -3? Increasing, right? So we know this is going to be positive here, and between -3 and 1, decreasing, you know that's going to be negative, and then increasing over here. So now we don't, what is this thing going to look like exactly? Well, f prime, positive, negative, positive. So it's going to be something like this. What's the halfway point between -3 and 1? It's going to be like -1. So -1 and 1. So here's your critical numbers right here. So the thing is going to look something like this. And that's not a very good, I want to draw a little smoother looking curve. Yeah, it's a little better looking. So there we go. Right? Negative between -3 and 1, and positive for greater than 1, positive for less than -3. That's it. Okay. Really? And then the next section here, what I want you to do is, we're given the functions and their derivatives. So here are the function graphs f on the left and their derivatives on the right. So I want you to go do the matching here on this spend a few minutes on this and we'll go over some of these together. That's going to be it for today.
So I'm matching the function with the derivative?
Yeah, you're matching the functions with the derivative. So you take, so here would be the functions, and here would be the derivative, the list of derivatives of these functions.
Okay. Okay.
But what I've seen in the past is sort of, you go through a process of elimination. It's sort of, you sort of gradually eliminate candidates until you get the right answer. I'm going to get a red pen here. Okay, so look at this, look at A. For A, you have this horizontal line here, right? What is the slope of that horizontal line?
Just like 1.
Is the slope of a horizontal line 1? The slope of horizontal line is 0. And so where do you see? It looks like 8, right? Let's go ahead and put 8 right here.
It didn't look like that.
Right, that's it. Next one, B, what does the slope of this line look like? So the slope is going to be what? Negative, positive, 0?
Be negative.
Will be negative. So where do you see the negative line? Right here. 1. Okay, and then C, what is C going to be? What, 10? Yeah, I'm thinking 10, right? That's going to be. And then this one here, you have this cubic function here. So that's going to be, what is this going to look like? It's going to be a parabola, isn't it?
Mm-hmm.
Which one is our parabola that looks right for this? Increasing, stops, still increasing. Which one is this going to be? Is the slope ever negative of this? No. So everything has to be at least above the x, touching or above the x-axis. Where is that going to be?
13.
I'm thinking 5, right? Because there's a parabola,
Okay, I get it now.
and it's 5, right? So 5 will go here. And then next, E, we have a parabola right here. So what's that going to look like?
That might be 13.
That'd be 13. It's going to be a line.
Then 3.
Could be 3,
And then 3.
or could be 12. I think it's going to be 3
2.
because of where this is, because the thing is negative all the way to this point, but positive thereafter. So to me, 3 looks like your best candidate for this. And next, this one here is going to be what? You're increasing all the way.
13.
So 13.
Maybe.
It's going to be a parabola again. It's going to be 7.
Yeah. Yeah, maybe 1.
Because the thing is increasing all the way up to is positive, all the way up to here. The negative between here and here, and positive. So you can draw the number lines. And this one here, G is going to be which one? Okay, we're negative right here in the middle.
Oh, I was looking at the other one.
Yeah, G. So decreasing, negative, 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 up until 0, then positive after 0. Where's that going to be? 12. Okay, and H.
Oh, what is this?
H, we have positive, we have increasing, increasing, then decreasing, decreasing. So positive up to here, then negative thereafter.
Shows like only,
That might be 11 here.
no.
It's positive. So 11, that's going to be 11. And then I, we have this thing, we have decreasing up to here, so negative, then positive, negative, positive. So negative, positive. So negative, or decreasing all the way up to here. So that's negative, then positive up to 0, then negative, so it's going to be this one too. And so really we're right out of class time, so we might talk about this a little more tomorrow. And we will just go on to our class tomorrow.
You want this now?